In this video, I would like to examine the variation within a data set. Actually, I want to look at the variation within two data sets and then compare the variation between these data sets. Right now, we don't have any data, so let's start with that. Let's use Excel to generate some random data. Now, as I've said before, if you don't know how to do something in Excel, just start typing the first few letters of the word of what you want to do. If I want random numbers, I'll type an equal sign and I'll start typing the word random. R-A-N-D. As soon as I get 4 letters in, there's only 2 options here. Excel has 2 functions. The first one, R-A-N-D, the rand function, returns a random number greater than or equal to 0 and less than 1, evenly distributed. All right, this gives me a random number, some decimal between 0 and 1. And rand between returns a random number between the numbers you specify. So if we choose the rand function, Excel is telling us, okay, nothing goes between the parentheses, so just close the parentheses and boom, there's our random number. And now if we drag this down, let's say we want to work with 20 numbers, so there's our 20 random numbers. The other function, the rand between, equal rand between. All right, now Excel is telling us if we use the rand between, then in the parentheses, we need 2 things, the bottom, comma, the top. So it looks like the first number, the last number. Now, before I do this, I want you to also keep an eye on column A. See those numbers. Now those numbers, those random numbers, they're going to change once I do something in column B, and I'll explain why in a moment. So let's say random numbers between 1 and 10. Now when I hit enter, 2 things are going to happen. Excel's going to give me a random number, and also it's going to recalculate all of these random numbers here. If I want the next 19 random numbers between 1 and 10, I'll just drag this down and look at column A again. When Excel calculates values in column B, it re-randomizes column A. And that's because with these random number generators in Excel, anytime you do a calculation anywhere, it's going to re-randomize. Now, if you don't want that to happen, what we could do is we could take this data and we can copy it somewhere else. So let's put it over here. And when we paste it, we just want to paste the values. So there's various pasting options. If we just paste the values. Now, if I click on A1, the first number here, and E1, the first number here, if you look at the function bar, it's like how Excel is describing what's going on in those cells. If you click on this first one, you'll see that is a random number according to Excel. And if you click on this one, it's this number. It's not generated by the random function. It's just the output value. So if I do a different calculation, you see column A is changing. If I change that 4 to a 5, column A is changing, but column E is not. So this is how we generate random numbers, and then we could copy it if you want to fix them, if you don't want them to change. Okay, so let's start over. And I want 2 sets of data. In column A, I want, let's say, we'll go with what we had before, numbers between 1 and 10. And let's use 20 of them. And then in column B, let's grab 20 random numbers between 1 and 100. All right, so now we have 2 sets of data. I'm going to copy this and paste just the values so these numbers don't change. And I'm going to delete these first 2 columns. All right, so now we have some data. We have set A and set B. And let's calculate. Now, you don't have to do this, but I'm just going to put some symbols in just for clarification. We have the mean. We have the standard deviation. And let's put in some borders here. What I'm also going to do is I'll leave one more cell because I want to compare the two standard deviations. Actually, I'm going to redo this a little bit and move this down. All right, we're good to go. Now, let's calculate the mean for set A and the mean for set B, and then we'll calculate the standard deviation for set A and the standard deviation for set B. Okay, so these are things we've done in previous videos. Equal average of set A, or column A. All right, so the mean for column A is 6, and is that 6.0 exactly? Yeah, exactly 6. And the mean for column B looks like 44.95. And I'm going to follow the rounding rules, and the rounding rules for measures of center say one more decimal place than your original data. So the original data is whole numbers. So our measures of center should have one decimal place. Same thing with the measure of variations. All right, so measure of variation, standard deviation. So that's equal ST DEV, and it's .S because it's a sample. Now I highlighted the 20 numbers before. Another thing you could do is just click on the column heading. So A colon A means everything in column A. All right, so there's our standard deviation. We'll round this again to one decimal place. And our standard deviation .S for column B. Now, if you watched my video on calculating the standard deviation by hand, you'll see that you'll be able to tell that these 4 calculations we just did in under a minute would take you between 10 and 20 minutes doing it by hand. Maybe closer to 10 minutes, but still 10 minutes versus 1 minute. Okay, so now it looks like set A has a standard deviation of 3 and set B has a standard deviation of 20.7. Now, which one of those has greater variation? Well, we can't say set B because it has a higher value for the standard deviation. It's 2 different sets with 2 different types of numbers. So to compare the variation between 2 sets, or to take 2 sets and say which set contains more variation, we have to calculate the coefficient of variation. And the coefficient of variation is simply divide these 2 numbers. We take the standard deviation and we divide it by the mean. So for set A, we could say equal standard deviation, which is D3, and divide that by the mean, which is D2. And with the coefficient of variation, we give it, it's normally given as a percentage, so you could times that by 100 or just convert to a percentage. This little drop-down menu here allows you to change the output form in Excel. Okay, so set A has a coefficient of variation of about 50%, and set B equal to standard deviation divided by the mean, and we'll change this to a percent. So the set with the smaller standard deviation actually has more variation in the set than the set with the larger standard deviation. And so this is what we have to do. If we're comparing if we're comparing two sets, we have to compare, and if we're comparing the spread or the variation between two sets, we can't just look at the raw numbers, the raw statistics. We have to convert those standard deviations and means into coefficients of variation. And that's why we use this coefficient of variation. It's all about comparison. You never need the coefficient of variation when you have only one data set. It's only used for comparison between two or more sets. All right, that about does it for the discussion on coefficient of variation.